So for this week's video, we're looking at addressable LED strips. So in particular, we're looking at the WS2812B strips. These are more popularly known as NeoPixels. These were popularised by the Adafruit brand, who wrote the library and sold the initial ones to the Western market. You can now just buy generic ones, which we'll have a look at the Aliexpress specials I've got in a second. In front of me I have a project I did a few years ago. So this is a 60 LED strip, say 60 LEDs per meter strip. And I've just got it cycling through a few programs which shows different colours in a pattern just as a test program. Each LED can be addressed individually. So you can set up a matrix to do like a display, or you could do effects based on filters. I've just got the board just driving a single colour round the loop at the moment, just so that the LEDs are working. For this older project, I have upgraded it just a minute ago to run off the Sparkle Motion board. This is the mini version from Adafruit, kind of in homage to the original NeoPixels. These LEDs run on 5 volts, specifically 5 volts. If you try and put 6 volts to them, they break immediately. So it has to be 5 volts. So you can't just use 4 AA's and then hope for the best. It has to be specifically 5 volts. To enable this, I'm running it off a Sparkle Motion board from Adafruit. This is the USB-C version, as everything has been converted to USB-C now. This is running off a battery bank. This is an Anchor one, and the pixels, the LEDs, can draw quite a bit of current. So this board is able to push up to 4 amps of current at 5 volts. The battery bank can only do 3 amps, but to do that, I think if I did the maths correctly, you can drive about 100 LEDs at full voltage for that full 3 amps. So you are limited by the amount of power that can go down these lines. The LEDs are quite bright. Here they're just mounted in a waterproof case. I wouldn't put it in water, but it's waterproof apart from the ends where I've cut it, obviously, and the control board. This was part of a costume at one point for Halloween. But back then it was run off an older battery pack. This was before the USB-C standard came about. So that's enough about the old project. Let me unplug this and bring into the new products. So we have here, this is from Aliexpress. Couldn't find it on eBay in the UK. So this is an Aliexpress direct one. They came quite quickly, didn't have to pay for shipping. Let me see what the listing says. So this is called a LED neon strip 360-degree round articulating pattern. So that's what it's called on the listing. I'll put it underneath so you can see. I've got the 2 meter version of it, and I bought it from a reputable seller, and it cost me about £18. Delivered, so it wasn't too much compared to if you buy them on the UK market. Obviously you probably could find it cheaper if you look now based on the listing, but because I was going in, I wanted to like a reliable seller, so I picked one of the better reviewed ones. This is a 50 LED per meter strip, so there is 100 LEDs in here, so that's up from what the ring was. So I'm going to connect it. Let me grab the camera. So I'm going to connect it to the Sparkle Motion board. I picked the version with screw terminals. This makes it easier to switch between the LEDs for testing. But as you would have seen in one of my examples, they do get loose over time. So if you're permanently or putting it in a costume, it'd probably be better to get the version that you can solder to, and then they'll be permanently affixed. But because I'm testing multiple strips, I wanted an easy way to undo and redo them. It seems like all of the LED strips use this type of connector, or this type of connector. It's a 3-pin one. I've got a couple of different versions in the packs I've received. And it's a keyed one, so you can only put it one way. And then if you're picking one of these up, I have found that the red is the 5 volts, the green is the data pin, and the white is the ground. So you can put the board, attach it to this, so you can have a standalone board. This is particularly useful for programming, because obviously your PC, not all PCs will be able to output 15 watts of power. So if you have a program that runs and says the LEDs demand 15 watts of power, and the PC tries, it can cause your USB ports to overload and then cause problems. So by unplugging it when you're programming it and then plugging it in when you're done, so plugging it into a USB power source like a battery works well. Or you can obviously run smaller tests. I think the PC can probably do up to 8 or 10 LEDs quite easily. So you can do a small test, and then when you want to roll it out to a larger thing, scale up your program so it covers all of them. This is going to run the same program as before. So this is just the LEDs going down the strips. With a short delay between each one. Obviously I've got quite a bit of light in here. It is not quite as bright as my other ones because of the diffusion of the layers, but you do get a 360 look at it. So if I kill some of the studio lights, and you have a better idea what it looks like. So I've turned off a couple of studio lights. I've left one on so you can see me. And it's quite bright on the camera. It's not quite as bright in real life, but you can see the distances between the pixels. Let's see when it gets to that point. So you can see the semi-light bright spots between them. It seems to be quite flexible. You have to remember that it is what the other one is. It's a strip of LEDs in the coil. So within this like silicon sheath, it is a strip in there. So you can't probably tie it into knots, but it's more flexible than I thought it would be. The material itself is quite nice. It's kind of a, I think it's a squidgy rubbery feel. And both ends are capped off. So it looks like it's meant to be relatively watertight. I wouldn't submerge it, but for costumes outside, it might work. So here I've just moved the big camera, which has better dynamic range than the DJI. And you can see that it's quite bright. This is set at the same levels the camera was set at earlier. I will turn down the camera slightly so you can see roughly what it looks like in real life. I think that's about a fair estimation of what it looks like in the room. So it's not amazingly bright, but it's quite bright. Probably would have benefited from being 60 LEDs a meter instead of 50, just to even out some of the dark spots between the LED gaps. I worked out it is 100 LEDs, because you program it on a LED by LED basis. So you say, run this program going one after another for 100 times, and when it gets to the end of the 100, it starts again. So I'm pretty confident that it is 100 LEDs in there, because I can't physically get into it without destroying it to check. This is sold, I'm not sponsored by it at all, so this is sold in 1 meter, 2 meters, 3 meters. I went up to 5 meters. But with LED strips of this type, I wouldn't go any further than 3 meters, particularly at this number of LEDs per meter, because the forwarding voltage drops. So once you get past, say, 150 LEDs, you can't drive them as brightly, or the data signal starts to break down if you try to drive them brightly. So if you were going to do this, you would need probably multiple strips, so one stops and then another one starts, or you need to eject voltage halfway down the strip, which is easily done, when the LEDs are exposed than it is when it's in this kind of sheath thing. So that's product one, so I'll unplug this. Okay, next up, I haven't tested this one off camera, so if it works, you'll be the first to see. If it doesn't, so they've titled, again I'll put it in the description so you can see, is WS2812B addressable ball LED lights, addressable. So how much did I pay for this one? Let's just check. This is for a string of 50, so this is half the number of LEDs of the other one. Again, I think this came in multiple lengths. So it looks like it could be daisy chainable, so we'll see what it looks like when we get out of it. So again, we have the 3-wire combination, red, white and green. I'm going to stick with the same belief that the colour scheme hasn't changed. So red is power, green is data and white is ground. Okay, so I'm going to run it using the same code I created for the other one. The other one was set up for 100 LEDs. So probably at the end of the code, there'll be a gap where it's sending information to LEDs that doesn't exist. I don't think this is going to cause an issue. It'll just be a pause in the animation. So they'll get to the end and then there'll be a longer gap when they're all on. And then it'll start again when it resets. So they're all lighting up. Yes. And then there's the gap I was expecting as it tries to send it to the other 50 which don't exist. And then it switches to the new one. These are addressable LEDs again. So I can send a different colour to each LED if I wanted to, which I probably will do in a future project. It's cool that they're daisy chainable. So they've given you a standardised plug that seems to be for this product on the outbound as well. So if I wanted to put, say, two 50s together, if I'm wrapping a Christmas tree in it or something, I can just daisy chain from one to another and then carry on going. So you probably could get 3 in a row if you wanted to, or maybe buy a longer one to start off with. The quality of the diffusion balls are quite good. They are plastic, hard plastic, so they're not soft plastic like a silicone. It's quite a rigid plastic. And it seems like the LEDs have been, no, it looks like they're clipped in. So it looks like the bowls are pressed onto an LED path. The wires I can see are in there, they're relatively thin. In principle, if an LED died, that would break the string because they're forward leading LEDs. So if the first one in the list, like a Christmas light, dies, the whole string will die. But you can bypass that by basically cutting it off and then resoldering on to the wires, and then the rest of the strip will continue to work instead of becoming e-waste. So they are repairable to a certain extent. Let's see how long they are, which is what I was going to do before I got distracted. So you now spread them out, you can see the addressable code going through it. So when it starts again, which will be in a second, you can see they run down the list as expected. They have given us that's probably a meter, maybe a bit more, of slack before the first LED. So you can run the control from somewhere else and then run it up to it. So this is without adjusting the settings. So this is overpowering the camera because it was set up differently. I'll adjust it so that I think it's about what I can see in the room. I want to say maybe about that. So that's kind of how bright they are in real life. I think that would be a fair estimation. Okay, so for the third Aliexpress purchase, I have some mini WS2812B LEDs. So these are 2.7 millimeters wide. This is far narrower than a standard LED. Let me grab them out here. Oh, some nice plugs again. They come pre-soldered, which is a big relief because I was worried about soldering these ones. Okay, so I have a meter of them. They're very, very small. So before we play around with anything else, let's just check that they work. Again, I'm using the same code. I think these are 60 a meter. Oh no, this is 160 a meter. They could be 160 a meter, so this code might not work. Or it might only work to a certain point, so we'll be able to see. Oh, they are bright. Are they 160 a meter? Yes, they are. Okay. So we have a string of mini LEDs. So these are tiny. If I grab, so this is about the width of a standard strip. These are, I think, 10mm strips. So probably within the flexible tube, there's something about this width. And these are probably the size of the LEDs in the globes. This is the size you kind of see most common. So if I hold it up against this, oh, they're getting quite warm. Okay. On our standard LED, you have 3 lines. You have power, data, and ground. So to make these work, they've put 2 of the lines on the back. You can't see because of the strip. If I grab, so you have on the front, you have the data line, you have the power and the ground. So they've used a double layer circuit board so they could get all 3 lines on here. If you compare it to a standard strip of WS2812B LEDs, which I have behind it, you can see that the actual physical LED itself is wider than the whole strip for this small one. So these could be cool for projects that need an intricate amount of space. So you're trying to squeeze them into, say, a helmet or something like that. During my testing, I did find that they get a bit warm. Let me adjust the settings so it's about right for the room. Yeah, it's about right. And just remember, I've still got my video lights on. I haven't turned those off. So these are significantly brighter than the other ones. This may be due to the being more of them. This is 160 per meter LEDs, and there's no diffusion here, it's straight on LEDs. You probably do need to put them on something that is a heat dissipator. So maybe sticking them to plastic might work, but probably metal would be better to dissipate the heat. Otherwise they'll get very hot if left on for long periods of time. I can start feeling them warming up in my hands just for a few minutes. Like with the other LED strips, they have come with the standard connector on both ends this time, so you can daisy chain them together if you wanted to. With 160 LEDs, I don't know if you would want to run more than one chain at a time. You'd have to probably introduce power at the second point again. So at this end, you would have to put 2 more, a power and a ground, on it to introduce additional power. Otherwise you won't be able to drive more than the 160, well, not full brightness anyway. If you're driving them at low brightness, you could get a long strip.